accepted, challenge accepted. The attitude is always challenge accepted. Challenge accepted, challenge accepted. The attitude is always challenge accepted.
And now, get ready to terraform your knowledge and scale up your infrastructure game, because Hila Fish is back on Dev Challenge Accepted stage.
Hila is a senior DevOps engineer from Israel and a true Terraform wizard.
She's got 15+ years of experience, and she's not just an AWS community builder and HashiCorp ambassador, she's DevOps rockstar.
Literally. Hila is also the lead singer of a cover band, and we'll enjoy her performance later today.
Now please join us welcoming Hila Fish!
Challenge accepted, challenge accepted. The attitude is always challenge accepted.
I love these guys. I mean, come on. I love them.
We love you too.
So, hi, everyone. Thank you for joining my talk. And this talk will be about Terraform practices. Just for me to know who used or have knowledge about Terraform, raise your hands. OK, so basically, this talk assumes you have some knowledge about Terraform, but I will try to incorporate some bits like basic information so you can be in the same baseline as me. OK, so in this talk, I'm going to cover best practices for enabling infrastructure scaling, team scaling, avoid pitfalls, and things like that. So I'm not going to introduce myself, but because these guys did it perfectly, so I can skip. OK, so Terraform implementations can be bad, ugly, but of course also good, and I will cover it here. Some disclaimers about the talk. I'm only covering Terraform in the sense of open source and not enterprise or cloud. OpenTofu, I assume, is part of it as well, but I haven't worked with OpenTofu, so I don't know how much it deviates from the regular Terraform, but have that in mind. Most of the examples that I'm going to share here are from the AWS cloud provider, but of course, Terraform works with all cloud providers. And again, I'll try to incorporate bits about specific things about Terraform, like the baseline, so you will know what I'm talking about. OK, so first of all, let's start with quick wins. Basically, things that you can achieve in a matter of minutes and leverage Terraform in a good way if you do that. So first of all, versions lock. You are all developers, and something that I want to say, Terraform is not only a tool for DevOps. Yeah, it's mostly used by DevOps, but if, for example, your company has a very good culture of dev enablement, then developers can use Terraform as well. So I believe this will help you as well. So in terms of versions lock, same as you lock versions for package JSON lock or requirements TXT for Python, same idea for Terraform as well. So you can lock modules versions. Modules in Terraform is like a class, let's say, in code, and then you instantiate the class. So modules is like a class. Providers is basically the ones you use, like AWS is one provider. You have providers for VMware, for Kubernetes, for a lot of things, even Jenkins. So you can also lock provider versions. And Terraform itself, you can also lock its version. Why is it important to lock Terraform versions? This is basically a meme from Anton Babenko, who's like the Terraform celeb, let's say. He's one of the main maintainers of the Terraform AWS models. And you can see here, a DevOps engineer or also developers wants to manage everything as code. And then sometimes the Terraform AWS provider issues interrupts them. So the thing about locking versions is to deal with the devil that you know. Because if you lock to a specific version, you know exactly what issues you need to encounter, unless otherwise you will have other issues that you wouldn't know about, because really every version has its own issues, if it's in syntax issues or whatever. So at least you can deal with the devil that you know. And so the good thing is to lock modules, providers, and Terraform versions. The bad thing is to lock in a way that will still allow breaking changes to occur, so make sure you lock to a major version. And the ugly thing is to have no version lock whatsoever. Trust me, you really want to avoid that. Next up, tagging resources. Why is tagging resources a good thing? It enables us to basically track our infrastructure costs. It allows us to understand which resources belong to which projects or which departments, and your FinOps team will be happy that you tag the resources. And if you don't have a FinOps team, congratulations, you're the FinOps team. So make sure you tag all the resources to make sure you have good tracking. This is only an example for some of the tags that you can set up. And also in Terraform, specifically in the AWS provider, you can set up a default tags, which means that whatever tag that you set in the default tags section, for example, managed by Terraform is like a classic example, it will get populated to any resource that you create with the provider of AWS, and then you set it up once, forget about it, so it eliminates the need to repeat yourself in the code. So tag everything that you can. Use default tags as makes sense. And PR enforcement, this is something that we will talk about at the end of this presentation. Basically, you can set up a scenario if there's no tags, like the PR has no tags for the resource, then the PR will fail to merge. So this is something that we can do, and I will, again, touch about it later on. The bad thing is to tag inconsistently, because it will be very hard to track things that way. And the ugly thing, no tagging whatsoever. And the last thing in the section of the quick wins, remote state. So by default, Terraform works with local state. What is a state in Terraform? Basically where it keeps the resources. Because once you run the code, let's say you create a VM, you run the code, it creates the VM. You run it again, it will say no changes needed. Why? Because it knows in the state file that it created a resource. So the state file is by default local, but if you set it up remote, then it's a good thing, because then you can work with teams, you can handle state lock much more easily, because you don't want people to work on the same state at the same time, because it could mess it up. So remote state is a good thing. This is how you define it in S3 bucket in AWS. Just set up a S3 bucket to keep the state there, and that's that. So remote state and the secured one is a good practice. If the state is backed up, for example, you can enable S3 versioning. And to handle a Terraform state lock, you can leverage either DynamoDB for that, or you can also use Atlantis, which is a Terraform pull request automation. I will touch about it as well, but it does it automatically. The bad and the ugly, local state, or the state is remote, but it's not secured or backed up. And if the state is not getting locked during implementations like Terraform apply or destroy, then it could be messed up, and it could be a nightmare. OK, next section is basically second nature, things that you should have in mind while working with Terraform. So first of all, using community models versus creating models yourself. So in the community, we have a lot of models that are used by millions of people that already do a lot of things that you probably have, like regular use cases, like creating VMs, VPCs, Kubernetes clusters, everything. So this idea is basically on the terms of why reinvent the wheel. If you have the same use case and it's very classic and you don't have these quirks inside, you can just leverage community models that have a lot of people using it. They are supported by the community. They are always checking if the features are aligned with the cloud provider's changes. So they're doing the work for you. So it's a very good practice to use community models. So use verified community models where possible, if it fits your use case, of course. Verified means that up until, I don't remember how much time, but they were actually signed in the Terraform registry. Now they removed the sign, and then you can verify it by seeing how many downloads it had. So if a community model has like millions of downloads, you can be rest assured that it is a good module. If you have custom models, but you still maintain them like community models with checks and everything, then it's not great, but it is still OK. And if you use community models without version lock, as I mentioned at the beginning, it also could be sometimes problematic. And the other thing is if you have a custom model and you don't maintain it because it will get drift, it will be very hard to maintain it when you want to start maintaining it again. So you really want to make it consistent. To have a consistency with maintaining your models, and to use unverified community models. So if you see a model that someone created and you don't know this guy and it has only like 20 or 100 downloads, don't use it. It could have a potentially malicious configuration, so stick to the ones that have like a very large number of downloads. And if you do have to create your own models, make sure that you make them stateless and clean and apply classic code best practices like make them generic, do not repeat yourself, KISS, etc. And I'll also touch about it a bit more. And the enforcements, I know I have a build-up to it, but trust me, it's a very worthwhile practice to do when it comes to Terraform. Next up, variables versus locals. So variables are the same as everything like in code, just variables that you set and it gets applied on the resources or module side. Locals is basically like variables, but their value don't change between Terraform runs. So if you run a Terraform apply or destroy, when a local is set up, it just have a static value that was compiled. I don't know if compiled, it's not a compiled, never mind. But a value that was calculated beforehand, and it just goes with it throughout the implementation. So for example, I can have a variable of a project and an environment, and then the local could be like required tags are the project and environment variables, but I want to have like a final definition of tags, and then I can do a merge between a resource tags and the required tags. And then whatever I do throughout the code, it just have this final definition of tags, and it uses it throughout the implementation. So on the module side, where like classes that we created, on the module side, the purpose of variables is to set up module configuration, but it means that you should really use and set up default or validation for the variables, because if not, and someone uses the module and pass the wrong values, it might have not good consequences. So make sure you have the proper default or validations to make sure that the person uses the modules will use it properly. And also on the module side for locals, you can think about it as a constant to be honored or relied on. So for example, if you create a bucket module, basically a module to create buckets in the cloud, you can have even like locals to set up any convention. For example, in this case, a bucket name. So if you want, as we know, bucket names in the cloud provider are unique throughout the entire regions, so you should have a unique bucket name. So in this example, you can just set up a bucket name convention that starts with the company name, for example, and whatever else you want. And that way, whoever uses the module are bound to have this name. They don't need to think about it, and you have a consistency and name convention, which is always a good thing. On the live side, for variables, live is when I call the models, right? So we said models are classes. Live is like the instantiation of the class. So on the live side, for variables, if I use them only once, I can just set up a default, and that's that. If I use the variables per region, etc., then I can use a file that is called tfvals, and then I can set up the values per region, and that's that. There is another tool that is called TerraGrant. I'm not going to touch it here because it's a whole story of its own, but if you don't use TerraGrant, your best bet is to have tfvals. And for locals, you should avoid using locals as much as possible because we want to keep the logic to the module side. So if you don't really have to have locals on the live side, try to avoid that. And data sources, basically, these are ways for us in Terraform to grab information from wherever. It could be from the cloud, it could be from other places, and this is a way to get dynamically information from wherever. So data sources is always a good thing because that way you know you get exactly the up-to-date information and not something that is hard-coded. So use TFVals where necessary if you have a lot of regions, for example. Utilize environment variables because then if you have those, it eliminates the need for you to create more variables in Terraform itself. Locals, use locals to hardcode one-time names, decrease code repeatability, and try to keep things generic as possible. The bad thing is to have multiple local blocks if not necessary. Terraform allows you to have multiple blocks. It's not too bad, but it will be hard for you to maintain it for the same reason as decentralized vals. You want to have one place to manage everything, so try to limit everything for one file, and I will cover it also in a second. Ignoring environment variables, same reason. And the other thing is to hardcode variables values where not necessary. If we need to change them, make sure they are changeable. Which leads me to file structure. So in Terraform, whatever you set up in the files, whether it's on the live side or the module side, if it has the suffix of TF, it will just run it and that's it. But for us human beings that need to maintain the code, we need to have some file structure that will help us manage it better. So we can take example from the community standard. So they have main TF file for the main logic of the code, variables for the variables, data for the data sources, and then versions for the providers and Terraform version. And for example, if you have, let's take an example. I need to create a VM, so the creation of the VM will be on main TF, but let's say the VM has other peripheral things like a load balancer that it needs or a security group. So in that case, you should separate them and have the files named under what they actually do for logical arrangement of the code. And this is something about modules. So if you created a module, try to think about if the module maybe could be separated to submodules or nested modules, and I will give example for that as well. In the community, we have a module for EKS to create a cluster of Kubernetes, and then a submodule of the node pools. And why is that? Because I want to create one cluster, but I might need to create several node pools, right? Same for a VPC. I need to create a VPC, but then a submodule of VPC endpoints, one through S3, etc. So this is something that I probably would need to do much more than one time to create the VPC. So the same idea. So if you have something like that, try think about separating them for ability to reuse it, but also for not having like a gigantic variables value, just one, not variables file, and it will get separated for each submodule. Okay. I know I talk very, very quickly because I try to push a lot of value to this presentation, so I hope that you are keeping up, and the slides are very good with, I try to put everything that I say in the slide so you can keep up with my Speedy Gonzalez pace. But this section I really, really like because it really concerns you. So applying classic code best practices to Terraform. I don't think anyone in the entire world, okay, yes, I will speak for the entire world, saying that I don't think that anyone thinks that Terraform is a pure programming language, okay? It's not, we all know, all good. But still, classic code best practices can be applied to Terraform as well. For example, before Terraform 0.13 version, you couldn't even loop over modules, and after this version, you could. So even HashiCorp that created Terraform realized that they should apply classic code best practices to Terraform, and this is why we should also do it as well. So what does it mean? Keep the code in source control management like GitHub, GitLab, Bitbucket, etc. Keep the code as simple as possible. In terms of human and clean, I've read an article by Thyssen Uhr. I'll have a reference page at the end, and you'll have a link there. Very good article, and he says, and I totally agree, and it applies not only for Terraform, but anything that writes any code, is that whatever you write as variables or as the code, if the syntax is correct, it will get executed. But we need to have the code clear and written in a human way, so us human beings will be able to maintain it better, because we need to think long term. We need to understand why we did things in a certain way. Sometimes one-liners are very clean, but they're not understandable, so maybe we should avoid one-liners and do something else. So we should write the code in a way that, yeah, the syntax should be valid, of course, but for human beings to be able to understand it, manage it in the long term, etc. Do not repeat yourself if you don't have to. Even functional programming aspects can be applied to Terraform. And of course, the code should be idempotent. OK, this is now the last section of this presentation, the long haul. Basically, things that you should plan ahead once you either want to start working with Terraform, or you already started to work with it, but you see some growing pains because the scale gets up. So this is stuff that you should think about. Structuring a Terraform codebase, there are a lot of ways to structure the Terraform codebase, and I want to show you now one way that worked for me in one of my previous companies that worked actually for the entire company. And let's see. So this is the structure that we had: team, project, cloud provider, account or environment, and region. How does it look like? So we have the live and the models. On the models, we have the IAM, VPC, whatever. And then on the live, we have BI for team, Airflow for project, AWS for cloud provider, production, dev, etc. for a cloud environment, and US East 1 for region. So this is the structure. Why did the structure work and worked for the entire company to use? Several reasons. The main reason was to set up Terraform as a platform. So basically, whenever a new team wanted to have the ability to create infrastructure in the cloud, they just onboarded to the same repository. We had basically, because of that, a standard for the entire company to use. We're doing things in the cloud in terms of infrastructure creation the same way. Great thing. We also leveraged code owners. So whenever a team onboarded to this repository, we created an entry in the code owners that that team has access to their team level in the repository, and then they can approve their own PRs, manage it, etc. So they have a full autonomy on their code. And they get out-of-the-box custom models to use, because let's say I created a custom model, it's in the same repository, so then other people can use it again, because when you create a module, it should be as generic as possible, so other people can use it as well, and not only my team. So they get out-of-the-box models to use. And practices enforcement that, again, I will touch it right in a second. Basically, tests and checks that run on the entire code, and they get it out of the box, which is great. They don't need to do anything else. So this is one reason for this structure. The second reason is small state files. So in Terraform, when we have the state files, I'll remind you, it's where we keep what Terraform did, like I created this resource with these properties, etc. So in Terraform, you have the state files, and Terraform itself creates dependency between resources. And if the state file is very, very big, sometimes Terraform creates invalid dependencies, which means that I could, and it happened to me once a long time ago, I had a very gigantic state file. I just changed a very small thing. I think it even was just a tag or something like that. And then on the Terraform plan, I saw it was going to change several things. I'm like, what? I just changed a little thing. So this could definitely happen when you have very big state files. So you really, really want to avoid that once you work with Terraform. So how the structure that I showed you solves that. So this is the reminder of the structure. And then the state file is kept in this level. So it means that the state file is only keeping the resources for BI team, for the Airflow project, in AWS production environment, in US East 1. That's it. Very small, very contained. The possibility to have invalid dependencies really lowers if you have very small state files, and then it will be much easier to manage Terraform that way. So the good thing by thinking ahead when you think about structuring the Terraform code base is that you can get to a phase of having small states set up. You can have Terraform as a platform, and then infrastructure and team scaling is very easy because everyone, it's like a machine. You just go at it and do it the same way. The bad thing, if you don't think ahead, is that organization changes might require you to have a restructure of the code. And really, it's not just in vain that it's in the ugly section. It could get very, very ugly. Always, at all costs, try to avoid huge state files. Invalid dependencies will definitely occur. Big blast radius, it will be a nightmare to manage, so avoid that. Let's talk a bit about Terraform execution. So aim for remote execution because we want our people to have an audit of what's going on. We want to avoid local credentials set up when we use Terraform, so remote execution is a good thing. We can also do a Terraform apply with a specific plan file, and that way we know exactly what we are applying. And setting up Terraform timeout. If, for example, I create an auto-scaling group and I select spot instances and I selected the very low price for the spot instances, then the Terraform will wait and wait and wait until eventually it will say, hey, sorry, we couldn't find instances for you because the price was very low. So it happened to me. It's a true story. And I was very impatient, so I clicked on Control-C, and it messed up my state, and I didn't have a backup. So yes. So avoid that by setting up Terraform timeout. That will allow Terraform to gracefully stop the operation and not harm anything in the state. The bad thing is to execute locally because you don't, again, local credentials, you don't, and you need, you don't have audit and what's going on in the cloud. And I will touch small bit about Terragrant. Terragrant is a tool that allows, it's basically a wrapper for Terraform, and you really need to think about the hierarchy before you jump the gun and work with Terragrant. So just have that in mind. Think hierarchy when you work with Terragrant. And the ugly thing is to execute locally and run Control-C like I did back in the day. I did it a very long time ago, and maybe now they fixed this behavior by now, but trust me, I don't want to find out, so I don't recommend you to do it as well, so try to avoid that. And last but not least, the practices enforcement that I talked about throughout the presentation. So basically, these are practices and basically tests and checks that you can implement, whatever you can possibly think of that you care about, that the company cares about, that you want to make sure that is checked against the Terraform code to make sure the code is in high quality state and any other practices. For example, you want to check if the code is readable. You want to check how much will it cost us to create those resources in the specified PR. You want to check if the resources are tagged, and if not, to stop the PR from merging, because you don't want to have any resources that are not tagged. You want to check if the code is reusable. You want to check if it's clean, right? So anything that you could possibly think of, the sky's the limit. So we can take an example from also the community model. We have it applied for all community models of Terraform AWS, but this is an example from the auto-scaling one. So you can see in this example that the check if the contributor formatted the code using Terraform FMT, if they added docs, and if they actually wrote a working code, which is used by TF-Flint. So again, this is one example, but you can leverage and do any checks that you want. For example, if someone created a PR that creates resources that cost more than $10,000, for example, alert FinOps team, for example. So you can do whatever you want. So the good thing is that you can have pre-merge linters, formatters, and logical checks. You can leverage GitHub actions for that. You can leverage CI pipeline checks. You can do whatever you want. You can also have Slack-bot drift reporter, because once you think about it, Terraform is the one that should manage the infrastructure in the cloud. But if someone created something in the cloud manually, then Terraform wouldn't know about it until you import it. So then it will have drifts. So if you want to prevent drifts from happening, you can create Slack-bot drift reporter that will tell you, hey, I ran Terraform, and I see there is a drift of ABC. And that way, you can make sure that Terraform is the source of truth for infrastructure management. And /or is that you can leverage Atlantis, which is a Terraform pull request automation tool, open source, completely free, where if you leverage it, when you open a PR, it will run the Terraform code for you. It will show you a plan, not apply it, just run the code to show you like a dry run, a plan. And then once all looks good, then you can apply it. Once you click on you type Atlantis apply in the PR, two things will happen. First of all, the code will get applied, and the PR will get merged. And then basically, it guarantees that the main branch is equaling to the actual environment, and then if you stick only to the Atlantis runs and you don't run anything manually, then you guarantee that there is no drift, and then you don't need the Slack-bot drift reporter. So Atlantis is a very good tool. I used it. I really recommend it. The bad and the ugly here is if you don't have practices enforcement. So if you don't apply practices enforcement, you could potentially have security issues and non-compliant configuration introduced to your code. And this is the time to, if you want, of course, the time to take your camera out. And this is some tools that will help you with open source enforcement and helpers. Very good tools that I use several, and all does different stuff. So it's a very good thing to have. OK. So I know I talked very quickly, and I covered a lot of things. But if there are two things that you should take from this presentation, are these two. So first of all, think about your code-based structure to enable you to have usage of Terraform as a platform and to set up small state files as much as possible. and to have practices enforcement, because you want to enable infrastructure and team scaling. You want to make sure that anyone that introduces code to the code base is in a high quality state, and any other possibly practice that you want to enforce. And like any other tool, don't use Terraform in an ad hoc mindset. You want to make sure that you are able to scale. You want to make sure that you understand the pitfalls of Terraform and know how to avoid them. And also think about that if everyone will use Terraform in the same way, then I wouldn't even be here talking about Terraform practices, because we're all doing it the same way. But we do it differently, and we will always have projects, because what is a project? Moving from one state to another. So Terraform code will evolve because of that naturally. So we want to make sure we plan ahead and plan for your future needs, and make sure your code is adaptable so you can do whatever changes needed without having to do a full-blown migration or anything of this sort. But again, mostly think about the tool that you're using and make sure that you adapt to their pitfalls, but also that your use cases are covered fully by using that tool. These are some references of things that I talked about throughout this presentation. So some about tagging, workspaces I didn't have time to cover here, but you should read about workspaces before you decide to use them as well. TSNU's blog post, and Superlinter for Terraform and for GitHub Actions bundle in general. It's a very good bundle. And that's it. Thank you very much.
Thank you, Hila. You just, just hit the second. Yeah, that was really impressive.
Thank you.
So if you have any questions to her, you can find her in the speaker's corner in this next break.
Awesome.
Let's send Hila off of the stage with big round of applause. Hila,
Thank
peace!
you.